Hi, my name is Muhammad Swaidi and I'm from Beea section 1. And firstly, this video is a video presentation on our project, which is a project for the course Beea 2374 Embedded System, which is a fundamental subject for Beea course. In this project, we must construct a simple design of Arduino-based system product with a minimum of 3 inputs and 3 outputs by using various type of input-output devices such as push buttons, solenoids, motors, and so on. Hence, this project entitled Passcode Door Lock for using servo motor is my project that I will be giving a demo about in this video. So, in compliance with the current pandemic, students are required to tackle this project individually and demonstrate the project with the help of softwares such as Arduino and also screen recording softwares. So without further ado, let's look at the coding of the project first. So first of all, here we can see the coding of the project. So first of all, we have included the library for servo motor. We have included the library for keypads, password, and also for the LCD. So here are the initializations for the servo. And here is the initialization for the LCD. And here is the initialization for the password class, which it's included in this library here. So most of it are just declarations of constants and so on. So here are the setup. So here firstly we set up the LCD into 16 columns and 2 rows, and then we declare the pins up here, the IO pins, and then here we also declared to the servo library that we have attached this particular servo pin to that motor, and then we write it as 0 to set it to the lock position. So here we attach 2 interrupt switches, which is first is the change password switch and the second one is the overriding switch, in which the change password switch, if switched on, it will enter a password change mode, which I will show you later. And then the second one is the overriding, which usually when there is a lock code door, there will be a control panel with the keypad on one side, and then on the other side usually there won't be any keypad here but just a push button to ease the access of people getting out of the building. It's usually at the inner side of the building. Okay, so here is just some loop conditions to ensure our LED doesn't go hazy. And actually for normal keypad operations, under void loop is usually just to get the key of the keypad. But since we are dealing with 2 extra buttons here, that's why we needed 2 extra interrupts here. Sorry, that's why we have this 2 ifs right here. So this is as you can see, this is the override switch, and this is the change password switch. So why I mentioned that it is in interrupt, because the benefits of interrupt is that when it is called, how does it know that it's being called, which we can declare it here, right here. So there are 4 stages, which is rising, falling, change, and the other one I forgot, but never mind. In which will determine how the interrupt program will be called, and this is the when it is called, it will find this particular class right here, which change state and overriding, which I've purposely put it down here so that it will be easier to see. So when the interrupt pins are called, it will change the Boolean state of this value and this value right here, and then it will hopefully get stuck with the outputs of the LED. In fact, I can actually just put this LED LED digital right here, but for the sake of just simplifying this interrupt class, I'll just leave it like this. So moving on, this is our loop function. I have mentioned it just now. And then this is our process number key, which if you this is our switch key. If there is a key press, if asterisk is pressed, it will reset password. Technically it's not reset password, it's actually clear password, but the reason I write it reset is that it resets the LCD to a clear state. And then default is the process number key, which we will process the key presses in. So in this particular program right here, if you notice this line right here, it counts the password length, which I set it to 4, and then when there is 4 key presses, it'll check the password. If the if the change password switch is off, and if the change password switch is true, it will record. After 4-digit presses, it will record the 4 digits into the new password. Okay, so like I said before, check password, which will go to the unlock class. Again, for simplification, I wrote it in another line. And then else, if there is a wrong password, it will display a wrong password, and then the buzzer will beep 2 times, sorry. And then the red LED will go high. And then it will clear the screen and then back to the intro screen. Okay, reset password, like I said before, it's just to clear the LCD out and put back the intro screen in there, which in this case, the intro screen is actually just enter password. Okay, change password is it copies it copies the 4 characters and put it into a string, convert it into a string, because to save a password, you need that password to be a string. And then it will set that password into the password library, the new password into the password library, clear the screen, and then display that new password once again. So here is the intro class, and then here is this is just mostly IO writings. And here's the unlock, which is quite long. That's why I put it into another class, because after the door is unlocked, it'll wait for 2 seconds, and then it will be locked again. And this timer right here is just a timer to let the servo back to its original position. So that's it for the coding. So now we will see the circuit itself. So here is the full layout of the circuit. Here is the door panel circuit layout. Here is the Arduino pinouts. Here is the hidden change password switch, and here is the override unlock switch. Okay, so let's power up this simulation right here in 3, 2, 1. Okay, enter password. So this is the intro screen. So like I said before, when we press this override button, the door will unlock, which is in 180 degree, and then the lock position is in 0 degree. So like when it is unlocked, it will show that the door is unlocked, and with a 2 seconds delay, it will go back into the lock position. Okay, so after that, let's try and enter the default password, which is 1, 2, 3, and 4. So now the door is unlocked again. It will go to the 180 degree position, and then for 2 seconds, it will go back to the 0 degree position. Okay, let's try and enter the wrong password for now on 1, 5, and if you notice, the input is in asterisk 9 and 3, wrong password, and the red LED lights up. So let's try again with the correct password. 1, 2, 3, and 4. The green LED lights up. So now, if we wanted to change the password of this project, we just need to switch on this switch. Both of the LEDs will light up, and when we enter the new password, instead of asterisk, it will just straight away show up the exact value 789, and this time I'll try and put 6. Password change, indicating that the password is safe. So when we switch off this again, both of the LEDs will turn off, and then when we enter 1, 2, 3, and 4, it'll just straight away write out wrong password. But when we enter the new password 7, 8, 9, and 6, it'll say that this is the correct password, because that's the password that we saved just now. That's it for the presentation. If there is any mistakes in the video or any comments that you want to leave on, please leave it in the comment section below, and a very big thanks to Puan Kausa for guiding me into this project and teaching me for quite some time already. So thank you for being patient with me, and that's it for this video. Thank you for watching.